Today, in this presentation, we are going to learn about the term called terminal velocity. Look at the demonstration shown there. A metallic sphere that is to be dropped through the highly viscous liquid, either castor oil or glycerin, that is to be filled up in a tall jar, through which a metallic sphere that is to be dropped. When the metallic sphere is dropped, initially the sphere it is accelerated, and on the sphere a downward gravitational force is acting. When the velocity increases, there will be a upward force which is due to the liquid that is acting in the upward direction. When the downward force is acting, when the downward force is increasing, the upthrust also starts increasing. Are you clear? When the downward force is acting on the body, when the velocity increases, the upthrust also starts increasing. After attaining a particular stage, the body will attain a constant velocity. That constant velocity is called terminal velocity. Look at the three diagrams. There are three forces are acting on the metallic sphere. One is downward gravitational force. The second one is the upthrust due to the liquid. The upward force acting on the metallic sphere due to the liquid is called upthrust. The third one is viscous force. Whenever any foreign bodies, when they are dropped within the highly viscous liquid, the viscous liquid, it won't allow the body to get in. That viscous drag, that frictional force between the metallic body and the viscous liquid is called, what is this? Viscous force or viscous drag. Are you clear? So, two upward forces are acting, one downward force is acting. When the net force balances the net upward force, when this stage reached, the body will attain the terminal velocity. After attaining the terminal velocity, the acceleration of the metallic sphere becomes zero, and the net force acting on the metallic sphere also becomes zero. Okay, in the next stage, we are going to learn about how to derive the expression for terminal velocity. Now, I will explain what is the meaning of terminal velocity. Here, let us imagine a tall jar in which highly viscous liquid is filled up. Either you can use castor oil or glycerin. So, in that castor oil or glycerin, the metallic sphere, a small metallic sphere that is to be dropped within the castor oil or glycerin. Let us imagine castor oil is filled up here. As soon as it is dropped, what will happen now? The metallic sphere, that one will be moving very faster because of gravitational pull. So, on the metallic sphere, a downward gravitational force is acting. Are you clear? Its value is mg. So, when it is descending down, initially the metallic sphere will be accelerated. So, each and every moment velocity will be increasing. Are you clear? And the two more forces are also acting on the metallic sphere. Here, when it is coming down, what will happen? Upthrust will be acting on the metallic sphere. Upthrust means there is an upward force that is acting on the metallic sphere. That upthrust is also due to this liquid. Are you clear? When the metallic sphere moves faster, are you clear? It is accelerated now. When the metallic sphere moves faster, the upthrust will also be increasing. Are you clear? As soon as the body gets accelerated, when it is moving faster and faster, upthrust will also be increasing. And one more force is also acting, that is called viscous drag. Because of its nature, highly viscous liquid, one more upward force is acting, that is called viscous drag. So, one downward force is acting and two more upward forces acting. Look at that. This is called, what is this? Viscous force. What is the name of the force called? Viscous force. Otherwise, it is called as frictional force. Are you clear? That is also called as frictional viscous drag. Here, one more force also acting on the same body. That is called, what is this? Upthrust. Are you clear? This is called upthrust. One upward, two upward force, one downward force is acting. So, how many forces are acting on the body? Downward gravitational force, and on the same metallic sphere, one viscous force is acting, that is also called as viscous drag, and one more force is also acting, that is called upthrust. So therefore two upward forces are acting and one downward force is acting. Apart from that, what happens? The body, it is slowly descending down. Initially its speed will be very fast. After attaining a particular stage, the body, metallic body, it is moving with constant velocity. It is not accelerated. That one will attain a constant velocity. That constant velocity is called, what is this? Terminal velocity. Are you clear? How it attains the terminal velocity? That we are going to learn now. Here, initially it is moving very faster. After attaining a particular stage, what happens? No, the net downward force will be balancing with the net upward force. Are you clear? Again I will repeat. When the it attains the condition of that balancing, look at that. The net downward force due to gravitational force will be balanced by the other two upward forces. Are you clear? So the net downward force must be balanced with the net upward force. When the stage attains the metallic body, it attains a constant velocity. That constant velocity is called terminal velocity. After attaining the terminal velocity Vt, the net force acting on the metallic sphere will be 0. The net force will be 0. Make a note. This is called as net force. You have to understand this. Body moves. Are you clear? But net force acting on the body is 0. Net force acting on the body is 0 means the acceleration of the body is 0. Because F is equal to 0 means the same 0 is equal to m into a. Are you clear? Acceleration is 0. Net force acting on the body is also 0. Acceleration is 0 means what it shows? The velocity is not changing. Velocity is not changing means it shows that it attained a constant velocity. It's clear. It is moving with a constant velocity. Finally, it reaches the ground. Are you clear? That constant velocity is called terminal velocity. That one happens whenever any metallic sphere, when it is dropped within the highly viscous liquid. That is very important. Are you clear? Now we are going to derive the expression for which one? Terminal velocity. Again, I would like to recall how many forces are acting. One is downward gravitational force and two upward forces. One is viscous force and another one is upthrust. So with the help of these three forces, is it clear? We are going to derive the expression for terminal velocity. Look at here. First I will write the expression for the downward gravitational force. The downward gravitational force acting on the metallic sphere is mg. First you have to write that one. Are you clear? Another, what is the next one? The upthrust. Upthrust acting on the metallic sphere towards upward direction is, what is the formula? Same formula can be written. Are you clear? Numerically these two are equal. Later we will explain. mg. Are you clear? What is the next one? Viscous drag. Viscous force. Viscous force acting on the, otherwise it can also be called as viscous drag, acting on the metallic sphere it can be written with the help of Stokes formula. Are you clear? 6 pi a eta v is a symbol for viscous force. This is from Stokes formula. A is the radius of the sphere, eta is called coefficient of viscosity of the liquid, v is called terminal velocity. Are you clear? This one is acting towards downward direction, this one is acting in the upward direction, this one also acts in the upward direction. Make a note. Now we have to get the appropriate formula for all the three. Are you clear? Now how can we write? Here, as I have told earlier, when the metallic sphere it attains the constant velocity, what is the condition for that? Look at that. Here the net downward force must be balancing with which one? The net upward force. Are you clear? So when both are balancing, this one is clear, this metallic body, it will attain a constant velocity called terminal velocity Vt. Understood? So when these two are balancing with each other, the net force acting on the body will be 0. Are you clear? So how can we write it? Clear? Look at that. The net force is equal to, how will you write? Net downward force minus the net upward force. We can write like this. Are you clear? How will you calculate the net force? From the Newton's second law we can write m into a is the formula to calculate the net force. Understood? How will you calculate the net downward force? The only downward force is mg. So there you substitute mg. Net downward gravitational force is mg. How many more upward forces are acting? Minus of. One is which one? The upthrust. Are you clear? That upthrust can be written as, what is this? mg. One more force is also acting. What is this? Viscous drag. Since it is acting in the upward direction, we can take it as minus. What is the formula for this? 6 pi a eta v. So like that we can write. Could you understand this? Here ma is equal to, here what is mg? Mg is nothing but gravitational force. How will you calculate the gravitational force acting on the body? Here by using a simple formula we are able to replace the m. Are you clear? How do you replace the m? Look at the formula. Density is equal to mass per volume. Are you clear? Here m to be replaced. M is equal to rho into v. M is equal to rho into that metallic sphere volume can be written as 4 pi 3 pi r cube. 4 pi 3 pi a cube. Are you clear? Pi a cube. So this is the formula to find out the mass. Substitute here instead of m, can it be written like this? 4 pi 3 pi a cube. 4 pi 3 pi a cube. And then density of the metallic sphere is rho g. So this is the formula to calculate the, which one? Gravitational force. Are you clear? Upthrust. How to calculate the upthrust? Each and every moment that metallic sphere it experiences a upthrust. That is almost equal to which one? The gravitational force. Therefore mg, this part, clear, that is to be written for which one? That oil. Therefore the same formula 4 pi 3 pi a cube. Clear, instead of rho we have to write the density of the liquid. Note down, this is the density of the metallic sphere, this is the density of the oil, castor oil. Are you clear? G. Same formula must be used. Minus of Stokes formula, viscous drag is 6 pi a eta v. Are you clear? Now the net force acting on the, clear, when these two forces are balancing, the metallic sphere it attains the terminal velocity. Therefore symbolically we can write it as, what is this? Vt. Are you clear? Now what happens? The net force acting on the sphere is 0. Are you clear? After attaining the terminal velocity, it is attaining a constant velocity. It is not accelerated. Therefore instead of a, clear, we can write it as 0. So therefore the net force acting on the metallic sphere will also be 0. Make a note. Are you clear? Acceleration is 0. Net force acting on the metallic sphere is also 0. So this factor becomes 0. What is the rest of the factor? This is the rest of the factor. Now we can write it as 0 is equal to 4 pi 3 pi a cube rho g minus 4 pi 3 pi a cube sigma g minus 6 pi a eta v t. In that format we can write. Are you clear? Now these factors, they can be, is it clear, combined. How it can be combined? Look at that. 4 pi 3 pi a cube. Is it clear? All other factors are common. Is it clear? So rho minus sigma, that could be written within the bracket, and g can be written outside. Are you clear? So this is the remaining factor, minus of 6 pi a eta v t. In that format we can write. Any doubt in this? Now our aim is to find out the expression for which one? Vt. Understood? Here this is the final step. Now I am going to write the same thing here. Here in the LHS part 0 is there. Now this equation that could be split. How it could be split? Look at that. 4 pi 3 pi a cube rho minus sigma G is equal to 6 pi A eta V T. In that format we can write. Our aim is to get the expression for terminal velocity. Here one is clear, A can be cancelled, this one could be written as square, pi 1 pi can be cancelled. Just is clear, interchange this, Vt is equal to, cross multiply this, Vt, what are the remaining factors here? 6 eta V, 6 eta V, bring it in the LHS side, 4 pi 3, and then here A square is there, rho minus sigma into G, this is the expression. What is rho? Density of the metallic sphere. Sigma is the density of the oil. Our aim is to get this one. Cross multiply this one to be cross multiplied. Are you clear? These factors to be cross multiplied. Vt is equal to 4 divided by, if 6 is brought here, that one becomes 18. This eta that can be brought down. And then what is the remaining thing? Here already this one is squared. Are you clear? What is the remaining thing? A square is there. And then rho minus sigma G is there. If this eta is already brought here. Now I am going to get the expression for Vt. Now these two factors can be cancelled. That one becomes 2 pi 2 divided by 9 eta. Are you clear? And then A square rho minus sigma G. So this is the expression for terminal velocity. Are you clear? By knowing the radius of the sphere, by knowing the coefficient of viscosity of the liquid, by knowing the value of density of the oil and density of the metal sphere, by knowing the G value, substitute all the value, we are able to get the expression for, we are able to get the value of terminal velocity. So, okay, so that metallic sphere, it will attain a constant velocity after reaching a particular distance. Are you clear? That one will happen when the net upward force balancing with the, which one? The net downward force. The upward force and downward force. Both of them must be balancing with one another. Only then that body will attain a constant velocity. Are you clear? Now we can draw the graph between which two? Are you clear? With respect to the time and velocity, we are able to draw the graph. Understood? Now we could draw a graph between the time that is to be taken in the x-axis and velocity of the metallic sphere to be taken in the y-axis. Are you clear? When it is descending down, initially the metallic sphere is accelerated. Due to the gravitational force, it is accelerated. Are you clear? When it is descending down, the upthrust value also slowly increasing. Are you clear? When it is accelerated, upthrust starts increasing. After reaching a point, what will happen? It attains the constant velocity, that is called terminal velocity. Are you clear? Initially, when it is descending down, its speed is increased. When the speed is increased, how the graph can be drawn? It is increasing. Are you clear? Very quickly it is increasing. After that, what happens? When the net upward force and net downward force, when both are balancing with each other, what will happen? The acceleration of the body becomes zero, the net force acting on the body becomes zero, and it attains a constant velocity. That constant maximum velocity is attained, and slowly it attains that acceleration, it is terminated. Are you clear? The acceleration, it is terminated means that acceleration, it comes to an end. It is not, it's clear, later it is not accelerated. Okay, if the metallic sphere is not accelerated means it attains a stage where the velocity becomes constant, the acceleration becomes zero. Are you clear? So finally it reaches the constant velocity. So the graph that is to be drawn, and finally it reaches a peak. So this is the maximum velocity attained, that will be a constant one. Throughout the journey till it goes to the end, it attains a constant velocity. Are you clear? Where acceleration of the body is, metallic body is zero. The net force acting on the body is also zero. Here only the net upward force and net downward force, both are balancing with each other. Initially, what happens? Because of the gravitational pull, it is accelerated. Suddenly, what will happen? The body is accelerated. Are you clear? Therefore, velocity also increases. So, this is the nature of the graph that is drawn between the time and the falling body which is passing through the highly viscous liquid. So, this is the point where that is called terminal velocity. Okay.